The second type of probability that we're going to look at is weighted probability. And this is a situation when the probability of similar events, like flipping a coin and getting a heads or a tails, but the probability of those happening is not the same. So this is something where, for some reason, we usually call it like a weighted coin or a weighted dice. For instance, another good example is when someone that's shooting free throws might be an 80% chance of making it. So he's got a better chance of making than missing. And there's a lot of different scenarios where this might come up. So our first example says a coin is weighted such that the probability of flipping a heads is 3/5. If the coin is flipped 3 times, what is the probability of flipping 2 heads? Well, the first thing we need to look at is to consider there's actually two ways to do this problem. One is to use a tree diagram, but a tree diagram, though a really good way to do the problem, gets a little tedious as you go through and do it. A better way is to say, okay, I want 2 heads, and so that would be a heads, and a tails. Well, the probability of flipping this right here would be you got 3/5 chance of flipping a heads times a 3/5 chance of flipping a heads times a 2/5 chance of flipping a tails. So that turns out to be 18 over 125. And that's going to be the probability of all the different ways that we can flip 2 heads. So the question is, how can we flip 2 heads? Well, the way that we can flip the number of ways we can flip 2 heads is going to be, you've got 3 coins, and I want to choose 2 of them to be heads. So 3 choose 2 just turns out to be 3. So the probability of, in this weighted situation, of flipping 2 heads is 18 over 25 plus 18 over 125 plus 18 over 125, or 18 over 125 times 3. Because there are 3 different ways of this happening, and each one of those separately is 18 over 125. So the answer is 54 over 125. So the technique to use is to use one example of how to do this, and then find out how many examples are the exact same as that one. Okay, another problem similar to this one says, this is that basketball player example. The basketball player makes 75% of his free throws. If he attempts 6 free throws, what is the probability he makes exactly 1? Well, it's not 75%. It's actually much higher than, it's going to actually turn out to be much higher than that, or much lower than that. And so the way we do this is, one example would be 1 make, and then well, here, let's use circles for a make, and then a bunch of misses. So if he makes his first one, then misses the next 5. Well, the probability of this happen. Now, here's a time when fractions are much easier than decimals. So I'm going to say 3/4 instead of 75%. So it's going to be 3/4 times 1/4 times 1/4 times 1/4 times 1/4 times 1/4. And so when you go through and do this problem, that is the probability of of all the different ways that you can make 1 free throw. So the question is, how many different ways can you do that? If you multiply this together, you'd get 3 over 4,096, by the way. So how many different ways can I make 1 free throw? Well, I've got 6 free throws. I want to make 1 of them, so I'm going to choose 1 to make. So it's just going to be 6 choose 1, which turns out to be 6. So there's 6 different ways to make 1 free throw. So the probability of making 1 free throw is just multiplying 3 over 4096 times 6, and you end up with 18 over 4096, which is the same as 9 over 2048. So the probability of, if you're a 75% free throw shooter, the probability of only making 1 out of 6 is 9 over 2048. It's a very, very rare occasion of that person actually only making 1 out of 6 free throws, because they're such a good free throw shooter to start with. 3 is now dealing with the weighted die problem. There's a 1/9 chance of an even number appearing and a 2/9 chance of an odd number appearing. If it is rolled twice, what is the probability that the sum of the numbers showing is 10? Well, when you roll dice, we went through and made a chart before. The probability, the different ways that you can get a sum of 10 is just going to be getting a 6 and a 4, getting a 5 and a 5, or a 4 and a 6. So we can calculate the probability of each of these. The probability of getting 6, 4 are 2 even numbers, and the probability of getting an even number is 1/9, so it's going to be 1/9 times 1/9, which just equals 1 over 81. So that's the probability of getting a 10. with these weighted die. Right? The probability of getting 6-4 on a non-weighted die would actually be 1 out of 36. All the different possibilities of 1 out of 36 if the die aren't weighted. In this case, because you're less likely to get an even number, then it's much less like probability of getting 2 even numbers. Okay, 55 is just it's getting 2 odd, so it's going to be 2 ninths times 2 ninths, which equals 4 over 81. And then the last one, 4/6, is the same as the first, it's just 1 over 81. So the probability that's happening of getting a 10 is you just add those together and you end up with 6 over 81, which can be simplified to 2/27. So the probability of getting a sum of 10 is actually 2 over 27, which is less than the 1/12 that it would be the probability of getting a 10 if the die was fair. And the reason why is because 2 of them involved all even numbers, and so that's why it was less likely, because our problem said the even numbers had to happen 1/9 of the time. Okay, the last problem we're going to look at is another weighted die problem. This one says it's the same scenario, but at this time when it's rolled twice, the probability the sum of the number showing is less than 5. So we got to think of all the possibilities. One of those is snake eyes, 1, 1. Then you got 1, 2, 2, 1. Then you got 1, 3, 3, 1, and 2, 2. So there's actually 6 different ways to do this. So we need to calculate each of them. Probability of getting 1, 1, 2 odds is, we did that in the last problem, 2 ninths times 2 ninths, which is 481. 4 over 81. We can kind of think about this a little bit, right? 2 odds, we know is 4 out of 81. 2 evens, we did last time, is 1 out of 81. And even in an odd is just going to be 1/9 times 2 ninths, which is 2 out of 81. So if we can just calculate each one of these. An even and odd we just saw was 2 out of 81. Another even and odd, 2 out of 81. An odd and an odd we know is 4 out of 81. Another odd and an odd is 4 out of 81. And the last one, an even out of even, is 1 over 81. So those are all the different possibilities. You just add up the numerators. You're going to end up with 6, and 6 is 12, plus 5 is 17. And so the probability of this happening is 17 over 81. So the probability in this scenario of getting less than 5, sum of less than 5, is 17 over 81. Well, I hope that explains and helps you a little bit with some probability problems. There'll be some more problems on your worksheet for you to work on.